In this video, we are going to go over drawing angle measures in standard position. And what we're going to start in today, but you're going to see that we don't always stick to the same type of measurement for an angle. We're going to stick to our unit of measurement, okay, is going to be degree. And degree, as you know from geometry, your degree measure is your rotation of your angle from a central angle. So we're going to be drawing our angles in the unit of degree measures. So we're going to get into drawing angles in standard position. So we have to figure out first what it means to draw an angle in standard position. So that's the first thing we're going to go over. Okay, drawing an angle in standard position. So standard position is extremely important. Okay, standard position. So we know when we have an angle is made up of two rays, and the angle of rotation is the amount of rotation or the amount of degrees that goes between the two rays. That's how much the angle opens up. So when you draw an angle, and you draw an angle in standard position, first you need to make sure that the initial side or the initial ray of the angle is on the positive x-axis. Okay, that's what it means to be drawing an angle in standard position. So what that means is you start the angle here. Okay, this is going to be the vertex of the angle. Okay, the origin will always be the vertex of the angle. And then, whatever the angle measure is, okay, you rotate counterclockwise. Okay, when the angle measure is positive. Okay, so if I have to draw an angle of 45 degrees, okay, I always open up this way. I rotate counterclockwise if you're in standard position. Okay, then if the angle measure, the notation, the symbol that we use is theta, the Greek letter theta. It's like a circle, and then you like loop it back around like that. Okay, angle measures theta. Okay, you rotate theta degrees, and then, okay, then you'll be at the terminal ray of the angle. So if the angle you had to draw is 45 degrees, you rotate 45 degrees counterclockwise, and then, okay, this is called, this red one is called the initial, okay, the initial ray. Then I will draw this little black arrow is the rotation. That is, you moved theta degrees, okay? And then this angle, okay, is theta, and this is the terminal ray. Okay, so this right here, this angle of rotation is theta degrees. Okay, vertex is always a central angle. In standard position, you always have the initial side going on the positive x-axis. Now, when we start doing this in terms of trigonometry, okay, we're going to be drawing these angles. The vertex will always be at the origin, but we're going to be drawing these angles on circles. Okay, so right now we're just drawing it on an x and y coordinate plane. But get used to seeing a circle here, okay? Because when we get into trigonometry, we're talking about angles that have something to do with circles. Okay, within the central angle of a circle, so if you imagine the center of the circle is the origin, okay, the central angle is the vertex as well. Okay, so this is drawing an angle in standard position. So we're just going to practice drawing those angles right now. Okay, you have to keep in mind these three things. Okay, so we're going to go over these 6 examples. Oh, I forgot to write what the first one was. And so you might want to write these all down or go through it one by one. So we're going to draw each angle in standard position. So the angle that we have to draw, the first one is 40 degrees. So remember, drawing them in standard position. So that's its initial side. That's its vertex. It opens up 40 degrees. I know right here, the positive y-axis would be 90 degrees. Halfway into quadrant 1 would be 45 degrees. So I'm going to rotate about this much. And there's my angle. Okay, so for now, as we just begin to draw these angles, I would prefer that you also include not only see how I made my angle, but that rotation symbol inside. Okay, not only is it telling me how much I've rotated, but it's also giving me the direction. And you'll see how it'll change when I give you different kinds of problems. Okay, so number 2, so that's all you have to do. Okay, number 2, theta is 100 degrees. So initial side. Okay, I'm going to rotate all the way to here is only 90 degrees. So I have to go 10 more degrees. That would be about right there. Okay, and I go put a little arrow here because that was my direction or orientation of rotation. And this is an angle in standard position in which the angle of rotation is 100 degrees. Number 3, theta is 180 degrees. So if I start, remember standard position means you always put your initial side on the positive x-axis. And now always, okay, notice this measure is a positive angle measure, so you always rotate counterclockwise. 180 degrees means I'm going to actually just end up, this is in geometry what we call a straight angle, right? 180 degrees. All right. Number 3, theta is 210 degrees. Okay, so standard position, you always start here. This would be 180, so I have to go how much more than 180? 30 more degrees, so it'll be about right here. I draw my terminal side, and that is the angle. Some people like to put little thetas inside there as well, okay? Showing you that's what theta, that's theta, that's theta, that's theta, but see how it gets a little bit more complicated, okay? Notice, the reason you want the orientation, this little rotation going on here is, if I didn't have this and I just had this initial ray and this terminal ray, okay, where's the angle you just drew? Is it this angle in here, or is it this angle here? And that little arrow of rotation is telling you how you made that angle, okay? 330 degrees is 30 degrees from a full rotation. So that means I'm starting here, and I'm going around, but I'm going to stop 30 degrees short of being one full rotation around the coordinate plane. Now, that's a good way of thinking about this. You need to start getting in this habit of thinking a little differently than usual. Okay, so we know from the, let me write this. Here's the x-axis, here's the y-axis, okay? To get from the positive x-axis to the positive y-axis, right, 90 degrees, 90 degrees, 90 degrees, 90 degrees. So 0, 90, 180, 270, 360, those are good mile markers for you, okay? Like, if we draw this theta is 210 degrees, okay? Oh, 210 is 30 degrees from 180, so I need to go 180 plus 30 more. Oh, 330 is just 30 degrees from one full rotation, so I know I'm 30 degrees from bringing just one full rotation. 400 degrees, this is an interesting one. 400 degrees means, okay, I start here. It means I'm going to go around one full rotation, but that's 360. So I actually go up 40 more degrees. Okay, so notice, I end up in quadrant 1, okay? 400 degrees is either going to fall in quadrant 1, 2, right? This is quadrant, if we forgot. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4, okay? It means I rotated a full 360 degrees, so I would be back at my initial side, and then I'm 40 degrees more, okay? Think about this. is this terminal side of number 1 the exact same terminal side as number 6? Are they in the exact same location? Start thinking about that right now. Okay, we're going to do a few more. So we're going to practice 4 more of these. So if you'd like to try the next 2 on your own, you might want to pause the video and draw it on your own and then see whether or not you got it right. Okay, so number 7 is theta. We have to draw an angle with 110 degrees of rotation. So 810 degrees means we're going to go around a few times here. Okay, so 810 degrees, it's positive, this degree measure, right? So we start here, and we're going to rotate once, that's 360 degrees. Now if I go around a second time, a full rotation, okay, that would be 720. So I know I have to go again. So if you're unsure, what you can do is you can just take 810 and subtract it from 360, and that means you still, okay, you still need to go 550, oh, sorry, not 550, 450 more degrees you still have to rotate, okay? That means I need to do another full rotation. That's 360 degrees, okay? 450 degrees minus 360 degrees, 90 degrees. So now I did 2 full rotations, right? 720 plus that 90 degrees. So I have to come up here, whoop, and I would end right here. And that's my terminal side. Doesn't really matter how many times you rotate around, your terminal side ends up on the positive y-axis. But this rotation at least tells you that this angle was formed by rotating around 2 full rotations and then 90 degrees more. Theta is equal to 0 degrees, so that means there is no rotation between the initial side and the terminal side, so it would just look like this. The terminal side would be sitting right on top of the initial side. Okay. Now number 9 and number 10 are a little different. Notice something different about number 9 and number 10. These are negative measures. Okay. These are negative angle measures. So what that means is, instead of rotating counterclockwise, when you have a negative angle measure, you rotate the opposite way. So you rotate clockwise. Okay? When you have a negative angle measure, you rotate clockwise. So standard position is still positive x-axis, but instead of rotating counterclockwise, we're going to rotate clockwise. So we have to rotate 130 degrees clockwise. So that's going to put us 90 degrees and 40 more degrees. Okay. So notice my angle of rotation here is in the opposite direction as number 7, because number 7 angle measures positive, number 9 angle measures negative. And the last one, number 10, theta is negative 50 degrees. So we start here. Okay, if you want to practice this one on your own, you might pause it and then play it. I'm going to travel clockwise 50 degrees. Okay, and then I'm going to lay my terminal side down. So this one ends up in quadrant 4. If this was just positive 50 degrees, I would be in quadrant 1. Okay, so that's it for just drawing an angle in standard position. Now we're going to talk about a few more things having to do with angles. What we're going to go over next is called coterminal angles. And so angles are coterminal if they have different measures but same terminal ray. So here's an example. Theta is 400 degrees. Oh, sorry, let's not start there. Theta is 40 degrees. Theta is negative 320 degrees. And theta is 400 degrees. And if we drew all of these, okay, if we drew these 3, and it would probably look better if we drew them all on the exact same coordinate plane, except that would be a little difficult to do. Everything will start looking the same here. Okay, and we draw these 3. Okay, theta 40 degrees, so initial side here, we're going to only go up 40 degrees. Okay, And that rotation right there is 40 degrees. And here is the terminal ray. The terminal ray is sitting 40 degrees from the positive x-axis. If we were to now draw negative 320 degrees, okay, initial side, negative means we rotate this way, 320 degrees is going to be 40 degrees from one full rotation. Okay, so that would be my angle that I would make, and this right here is 40 degrees. This right here is 40 degrees, and 400 degrees, positive 400 means I go around once, 360, I'd have 40 left. Okay, my angle of rotation in between the initial side and the terminal side would be 40 degrees. Okay, all three of these angles have different measures, but their terminal ray ends in the same exact location in 2-dimension. Okay, that's when you have what's called coterminal angles. So 40 degrees, negative 320 degrees, 400 degrees, these are examples of what's called coterminal angles. Now, are these the only three that are coterminal with each other? No. There are an infinite number of angles that are coterminal with any one angle. If I just keep adding, there's one number, okay, there's an angle measure that if I just keep adding or subtracting it, I'm going to keep ending up in the same spot. How long, okay, how much rotation? If I'm right here, how much do I have to rotate so that I end up being back right there? What's one full rotation? 360 degrees. So if I keep adding 360 degrees, right, 400 degrees, my terminal ray is going to be in the same spot. So if you keep adding or keep subtracting 360 degrees from any given angle, you'll hit every single coterminal angle to that one given angle, okay? So let's write that down, okay? So coterminal angle, you take theta and you add 360 degrees. Now, what I'm going to put here is you can either add 360 degrees an infinite number of times, or you can subtract 360 degrees an infinite number of times. So what I'm going to do is I'm going to write 360 degrees times n, where n is any integer, but n can't be 0. Otherwise, it'll just be theta. Okay, so what this means is, if I took theta, and if n was 1, if I add 360 once to theta, I'd be at a coterminal angle. If I did if I set n to be 2, that means I'm going to add 360 twice. I'd be back at the same exact terminal spot. Okay, so let's do this. Name one negative and one positive coterminal angle with theta equal to, let's say, 500 degrees, okay? Now notice, this also accounts for negative, because an integer, if I was to let n be negative 1, right, that means that what you're also doing is subtracting 360. So if you're going to name a negative coterminal angle, the angle you give must be negative. That's what it means, okay? That's what it means to be a negative coterminal angle. Not that you got there by subtracting 360. The angle you give has to be, okay, has to be negative. So how do you find coterminal angles? You add and you subtract 360 degrees. So 500 minus 360, okay? 500 minus 360 puts us at 140, okay? So is that a negative coterminal angle? No, I have to subtract another 360, okay, if I'm going to get to a negative coterminal angle. So one angle that's a negative coterminal angle with 500 would be negative 220, okay. And then a positive, well, we actually already know one of the positives. We could just use this 140 degrees. If you wanted to find another one, you could take 500 and add 360. Okay, you would get 860 degrees. Okay, either of them are fine. And then if you just kept subtracting 360, you would keep hitting all negative coterminal angles. If you keep adding 360, you would keep hitting all positive. But what you have to keep in mind is there are an infinite number of coterminal angles with any one given angle. And if it says a negative coterminal angle, the angle you name must be negative, the positive angle must be positive, and coterminal means that their terminal side, that's why it's called coterminal, their terminal side is ending in the exact same location. Okay, so that's it for coterminal angles. Next up, we're going to discuss something called quadrantal angles. So the word within quadrantal is quadrant. Okay, we have 4 quadrants, right? 1, 2, 3, 4. And if you have what's called a quadrantal angle, these are actually special angles. A quadrantal angle actually does not fall within a quadrant. So what that means is you're falling on an axis. Okay, so we have 0 degrees, okay, 90 degrees, 180 degrees, 270 degrees, and anything that's coterminal. And any coterminal angles with 0 degrees, 90 degrees, 180 degrees, 270 degrees. Okay, so that's why I'm not putting 360 up here, because 360 degrees is just coterminal at 0 degrees. So 0 degrees is considered a quadrantal angle because its initial side and its terminal side are both on axes. Okay, so it doesn't fall within a quadrant. They fall on the quadrants. 90 degrees, okay, notice, does not fall in a quadrant. 180 degrees, okay, terminal side does not fall within a quadrant, falls on the quadrant. 270, okay, terminal side does not fall within, that's what it means, do not fall within a quadrant, okay? It means that the terminal side is not inside of a quadrant, okay? So these are special angles, they're called quadrantal angles, and we're about to see why we have to know that there is a difference between, or that these are kind of a little special, I should say, ones that don't fall within a quadrant. Okay, so these are called our quadrantal angles. Okay, the next piece of this lesson is dealing with what's called reference angles. Now these are going to be extremely important, so please make sure that you feel super comfortable with reference angles, because what reference angles are used for are evaluating trig functions. So we haven't gotten to that yet. That's the next thing we're going to start doing, is evaluating trig functions. However, you can't start evaluating them if you don't understand a reference angle. So first off, only non-quadrantal angles have reference angles. Okay? So a given angle has a measure of theta degrees. If you're going to note an angle's reference angle, okay, if you call the angle theta, you call its reference angle usually theta prime. So it's like the theta symbol with an apostrophe there. That's called, so this is called theta, okay, and then this is called theta prime. And in this case, it doesn't mean that it's, you know, in geometry, sometimes you use that prime when you were noting that it was a rotation where it ended up after the rotation. That's not what this is referencing. Theta prime is just the symbol that means when you're talking about angles that this is the reference angle to that angle. And a reference angle will always be greater than 0 degrees, but less than 90 degrees. And once you write that down, okay, if you have to pause the video, make sure you write all of this information down. Now what we're going to get started with is getting an angle's reference angle. So it goes differently based on what quadrant you're in. If you're in quadrant 1, okay, so theta is 40 degrees. So I'm going to draw theta. So this is theta, okay. We rotate up 40 degrees, okay. What's true about any reference angle, okay, any reference angle, okay, theta prime has same terminal side as theta, okay? So the reference angle here is going to have the same exact terminal side, so it's going to share here, okay? And, okay, and then initial side doesn't really have to be initial side or just like the other side of the angle, is closest part of x-axis. So is this terminal side closer to the positive x-axis or the negative x-axis? The positive, so it goes right here. So theta prime is actually just the same as theta, okay, 80 degrees. So if I drew that, okay, theta is 80 degrees, it's about right here, that's 80 degrees there. The reference angle has the exact same terminal side, okay, and then closest piece of the x-axis, is it the positive x-axis or negative x-axis? Positive. So if you notice, theta prime, okay, here's theta prime is actually the same as theta here, it's 80 degrees, okay? This happens in quadrant 1. Theta, if you are in quadrant 1, theta will always be the same as theta prime, okay? Well, I should say, I jumped the gun on that one. I'm going to erase that, and you need to erase that too. Okay, that's taking into account that we are sticking between a rotation of 0 and 360 degrees, okay? We'll do a few more of these and you'll see what I mean, okay? So take away that note that I had just put there. We'll scratch that, okay? Scratch that out if you wrote in pen, okay? Erase it, and we'll talk about it after we do all the quadrants. So quadrant 2, okay? Theta is 100 degrees, so let's draw that. Okay, so we rotate, so we're here. Okay, so theta prime, okay, the reference angle to an angle that's 100 degrees, okay, it has the same terminal side, but where's the closest x-axis, here or here? Here. So this is theta prime. Okay, theta prime is how many degrees? 80 degrees here. Okay, so they share the same terminal side. However, the other side has to be the closest part of the x-axis. You never go to the y-axis. Never, ever, 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 ever. Okay? The reason we do this is because we have to standardize how we evaluate trig functions, and we always need to make sure that we're coming to the closest x-axis, okay, because someone set that before us, and not going to the y-axis. Okay, so the next one, 150 degrees. So theta, I would go all the way around, and I would be right about here. Okay, so that's theta. Okay, this is theta, right? This is theta. Okay. Theta prime shares the terminal side and then goes, and the other side of the ray would be the closest x-axis, part of the x-axis, which would be down here. So here's theta prime. What's theta prime here? Theta prime is 30 degrees. So notice, if you're going to be inside a quadrant, and you're going to take the terminal side, and then you're going to go to the x-axis, the closest x-axis, that's why your reference angle is sandwiched between 0 and 90 degrees, because it's always going to be somewhere between 0 and 90 degrees. Okay, so that's quadrant 2. So notice, in quadrant 1, your reference angle was here, okay? In quadrant 2, your reference angle is here. Now let's look at quadrant 3. Okay, theta equals 210 degrees, and theta equals 260 degrees. Okay, so 210 degrees, I would be rotating this much. Okay, and that would be theta. Okay, so if I wanted to draw theta prime, or the reference angle, I've got my terminal side. Okay, now where's the closest part of the x-axis? Is it the negative x-axis or the positive x-axis from the terminal side? It's right here. It's the negative x-axis. Okay, this is theta prime. What is the degree measure of theta prime? Theta prime is 30 degrees. Okay, another piece of information you want to include in your reference angle. Okay, it's actually included right here. You never name a reference angle negative. Okay, a reference angle is always a value that's between 0 and 90 degrees. Next up is 260 degrees. So, initial side, we rotate, we're 10 degrees short of being at 270 degrees. And now the reference angle for 260 degrees, okay, shares the same terminal side. Now, which side is closer, the negative x-axis or positive x-axis? The negative. So this is your reference angle, okay? That angle measures 70 degrees, okay? So the reference angle of 260 is 70, the reference angle of 210 is 30, the reference angle of 150 is 30, reference angle of 100 is 80. So now let's do quadrant 4. Okay, so we'll do theta equals 300 degrees and theta equals 310 degrees. Okay, so 300 degrees theta. That means we go around initial side counterclockwise. 270 plus 30 degrees puts us about here. Okay. We want the reference angle of 300 degrees. So the reference angle of 300 degrees, okay, shares the terminal side. Now what's closer, the negative x-axis or the positive? The positive. So here, this angle right here, that's sandwiched between the two sides, that is your reference angle. And the reference angle is 60 degrees. 310 degrees. Okay, 310 degrees. So I'm going to draw that angle, 310. So I'm going to go around, right, initial side. I'm going around right about here. Okay, that's 310 degrees. The reference angle of 310 degrees is always going to be the same, okay, because you're going to draw your terminal side, which is the closer x-axis, the positive. So that rotation between those two, okay, what's that going to be? Theta prime is 50 degrees. Okay, so be mindful of what quadrant you're in. Notice in this quadrant, your reference angle always falls there. Positive x-axis with the terminal side. In quadrant 3, it's always terminal side with negative x-axis. Quadrant 2, it's always terminal side with negative x-axis. In quadrant 1, terminal side with positive x-axis. Okay, so let's just do a few more of these examples, and then that's going to be it. So we have to identify the reference angle for each of these angles. 400 degrees, so 400 degrees starts here. I would rotate around once, and then I would come up. Okay, now your reference angle is going to be terminal side to the positive x-axis because we're in quadrant 1. So how much measures in there? Well, that's 360 plus 40, right? Theta prime is 40 degrees here, okay? Number 2, negative 100 degrees. So we're going to draw the angle, okay? So we're going to go back 100 degrees, okay? Now the reference angle here is always terminal side to closest x-axis. So the closest x-axis here is the negative, right? We're in quadrant 3. So this is theta prime. So theta prime, okay, just because this is negative does not mean this is negative. It just means that's the type of rotation we did. We went backwards. So if this is 100, and to get all the way around it would be 180, that means that theta prime is 80 degrees. Okay, so that's it. Okay, that's reference angles.